the graduate engineers, you would be surprised even if you talk to them about the Ohm's law, resistance, the basic things which we studied in the 10th standard physics. I mean, they are confused. They say, I know, but I can't answer now. This is the answer I get when I sit on the interview boards or interview panels. Even on the interview panel of the electricity board of the Maharashtra, when people come there for the interview and they are electrical engineers. So education, I don't blame them. I don't criticize them. Please don't misunderstand me. But the institutional support what they got, after their graduation, what experience they got, so good number of electrical engineers, good number of electricians even. There's a lacuna of lot of electricians in the cities, apart the rural areas. Just 3 months before I saw a case, I personally had gone to see what it is. One lineman of the state electricity board, he went on a pole and he had given a signal and all precautions were taken to disconnect the power supply, and he got electrocuted on the that pole only, the transformer pole, DP pole they call it, and he was hanging there. Young boy died. So there are so many such casualties happening. There are open wells being used in the rural area for agriculture purpose. Many times people jump into for either setting some cable or wire or setting some floating motor in that well, or they go for swimming in that well and they get electrocuted because of the current flowing into it. So these are the small things, but the buildings, those are like the building where I stay is about 30 years old building. This building basic backbone electrical installation, I don't think it must have been done to cope up the number of air conditioners being used, the number of electrical appliances being used, number of geysers being used. So we are overloading. We got refurbishing done, but how many buildings they are concerned about? The society, any residential society, we talk to them, they talk about the cost cutting. They talk about the cost cutting of the backbone installation. Excuse me. I'm sorry. So they talk about the cost cutting in terms of the backbone installation, but they want to enjoy the luxury of having the all electrical gadgets and electrical facilities. So this mindset of the people needs to be changed, and if that is done, I think 50% of the situations can be averted. 50% of the accidents can be averted. Now we have further challenges of lithium batteries, lithium battery storage, and electrical cars, and use of electricity for many other purposes. So with all that, it is a good, the initiative facilitated by Blue and Grey and supported by the Fire Safe India Foundation and Focus. And the most important speaker, Mr. Gopakumar, is available on his busy schedule to give us some tips to get educated. I know the audience must be more interested. In the Bombay data I was looking at, Bombay every year they claim that 300 fires, 300 casualties due to the fire, and mainly the fires, 90% fires due to short circuit. This is difficult to accept and digest. The reason is, if you don't have the mechanism for the proper investigation, you don't have the machinery for the proper investigation, I doubt we can always blame electricity. But whatever little we think that electricity is a problem or electricity poses a problem, if it is not handled properly, if it is not taken care of properly, that is the education Mr. Gopakumar is going to give us. With these few words, as the icebreakers, I just would like to conclude and don't come in between you and the most eloquent speaker for the day. Dominic, thank you so much, and I make it over to Mr. Dominic now. Thank you.
Thank you very much, sir. I think Mr. Dominic is on mute. Thank you very much. I will, without wasting time, I will start. Mr. Dominic, are you there?
Yeah. Of course, sir. You can go ahead, sir.
So, first let me share the screen. I hope my screen is visible now.
Yeah.
And it's screen. Yeah, it is screen. Yeah. So, thank you very much, Deshmukh sir, and thank you very much, Mr. Dominic. Today we are going to have the next session, part 4 of our webinar series. So far we had 3 parts, and we are astonished to see the participants at the beginning of the program itself. We have more than, I think, 150 participants, and every program I think we have about 300 plus participants for our webinars. It shows that people are really interested. Now today we are going to discuss about the methods and tips to make electrical safety audits. Electrical safety audits in the sense how to ensure that the systems are working properly finally. So this the IEC standard IEC 60364 is the basic standard which is used as electrical audit or electrical safety verification. That means inspection and testing across the globe. And this standard is made by IEC TC64, and the technical group is MT12, where I am a member from India. So this standard called as 60364 Part 6 is used worldwide for testing or inspection and testing of an electrical installation, which is used for final verification as well as for periodic verification. So before going to the parts about CAPE, we are into electrical safety. We were doing lot of electrical safety awareness programs under various forums. As Mr. Dominic was reading, 1,000 webinars or 1,000 programs, how this is possible. I have almost every day, sometime, more than one program nowadays. Yesterday, there was a webinar, sorry, not a webinar, it was a live program organized by ISRE in Chennai, IIT. And today is this, almost every day, classes are going on. So we are very actively into electrical safety. In electrical safety, we started a new solution, which is called as Solve, Safe Operation of Low Voltage Electricity. It's a digital platform which ensures that easy follow-up of these standards are possible. The second part is our we call as the structural earthing or foundation earthing system, global earthing system, and structural lightning protection system means without the earth electrodes in soil, nowadays modern buildings can have all kind of earthing and electrical safety. This is our one of the business, mainly for lightning protection and for safety. We also do industrial plugs and sockets, and we are also into EMI/EMC, the risk assessment, design, and the implementation in various projects. About the company, we started in 1997. We have more than 200 employees, and we have 2 factories, one in Chennai and the one near to Kanyakumari, where we start from, which is Cape Comorin, the name of Kanyakumari during the British time. We make most of our products are made in India, except a few, like some of the surge protective devices are imported. Otherwise, all the components are made in India, tested as per the latest IEC standards. This year, 97, we are completing 25 years of our existence, and we are coming out with the solution called as Solve, digital platform which ensures safe operation of low voltage electricity. So our subject, please understand that we are talking about low voltage electricity. Then people ask, what exactly is low voltage electricity? Low voltage electricity, the definition is anything up to 1000 volt AC and 1500 volt DC is called as low voltage electricity. So we are talking this the lesser voltage. Probably in your factory or in your installation, if you have the high voltage system such as a transformer, of course that is also included in the our technical seminars. Now regarding the safety situation in India, you are aware that last program we conducted in 4th of February, and on that particular day there was or I think 2-3 days before, there was a fire accident, and this particular news came on 4th of February that 70% of the fire incidents are due to short circuit, and BMC want the housing societies to conduct electrical audit. So our today's program is mainly to explain you how exactly and what exactly you can do an electrical safety audit to ensure safety in an installation. Now, before going into the part, actually I would like to show this picture and explain a little bit how we are making safe India. In the picture, what you are seeing here, this is a a wooden pole, or I would say it's a bamboo pole. And on the bamboo pole, you can see a cycle rim, a cycle frame. Such a bamboo pole and cycle rims were installed in schools, hospitals, the Anganwadis and small government organizations across 3 to 4 states in India. Thousands are installed for the purpose of protecting people from lightning protection. We call this as joke, we call this as cycle tire lightning protection. This is actually protected, promoted unfortunately by some of the government agencies without knowing, without understanding the seriousness of it. Actually, in the picture where you are seeing, there is a cycle rim and there is a wooden pole, and children are standing under this wooden pole. And if a lightning strikes this pole, for sure, all the people nearby, they are going to be in deep trouble. So why I showed this this picture is to tell you that without understanding the seriousness, people simply jump into the subject of safety and start educating people. Then always it's a trouble for us. One moment, I will just hold on for a minute. I have some drilling sound coming. Just a moment, please. Somebody is drilling on my nearby, so that I can. Sound is disturbed. So okay. Anyway, they will stop it. I just instructed. Okay.
No, it's okay. It's not disturbing. There's no. So yeah, we could hear. Everything is very clear. Not an issue.
Okay. So this, cycle tire and this wooden pole has been installed in schools and villages, and there are some NGOs operating with the CSR fund. Crores and crores of CSR fund has been spent for educating really, sorry to use the word nonsense. So such nonsenses are being educated under the label safety. So this is the situation in India. Now, coming back to the next slide, the funny thing is, last month BBC had covered this cycle rim as a innovative lightning protection, and they published it across the globe. I actually got the information from one of my friend in USA, and he sent a mail saying that how come in India, BBC is reporting that cycle tire will protect lightning protection or people from lightning. This was actually, a big disaster. So basically, this is the safety, what we are doing in our buildings, and this is our mentality. When it comes to electrical safety in low voltage system, users, most of the users, in Tamil we say, switch pota light area. That means you switch on, when your switch is on, light should be on. This is the maximum requirement of a consumer, and the people say, I have only money to spend up to this. I don't have money to spend more than this. As a result, making the switch on and the light is on. This is one part of electrical engineering, but the other part is safety. You have to spend sometime more money to ensure that your electrical installation is safe. So first is this kind of, the mentality should change. The second one, corporates, safety first. Most of the time, these logos and articles and all these things are, only in paper and in advertisement. Why I am saying this is in paper and advertisement, in the next slides, you will be able to understand why I made this statement. Designers, a lot of designers, they always argue with, especially when I tell that what you have to increase, and people always say that, where is it written in the regulation? We will do only if this is written in a regulation. Even if we say, look, this is written in a standard, then they say, oh, no, standard is not correct, regulation. So you should rewrite it in the regulation, then only we will follow. This is another kind of, issue. Then contractors, of course, no one is bothered. Suppliers use electrical safety as a marketing tool. Whenever a new product comes, then, with a big banner, electrical safety is educated, or the product is educated in such a way that it offers some electrical safety. Of course, it is true, but the actual situation is a little bit different. When it comes to inspection and audits, what is it? Most of the time, the inspection and audit, safety audits, what we do is earth pit resistance measurement, which I told in low voltage engineering, earth pit has nothing to do with electrical safety. Then the other argument people ask is, why don't the inspectorate do this job? Of course, it's not possible because the low voltage system is below the notified voltage in most states. The electrical inspector's responsibility is above the notified voltage. So low voltage is basically not their job. Of course, if you have some DGs or some generators, it comes under the purview of the inspectorate because they have to check whether backfeeding and other accidents are not happening. So basically, low voltage is there is no one to guide you how to do it. But of course, the regulations are very clear what you should do. This I will explain in the next slides. So basically, inspection and audits in LV system. What is it? I'm just showing you a standard. IS 732, it is not a standard, it is a code of practice. See, in the Bureau of Indian Standards publish two kind of documents. One is the code of practice, like National Building Code, National Electrical Code, a code of practice of electrical wiring, National Lighting Code, and so on. For example, the IS 2309, code of practice of lightning protection. So, and then standards are there. Now, if we look at the regulation 12, part number 2, what it says is, for achieving safety in a building, you are supposed to follow the code of practice. And the next regulation says, all the products used in that particular installation shall satisfy the respective IS standard or the IEC standard. So basically, code of practice is for an electrical installation, and the standard is for a product. Now, IS 732, 1989, Code of Practice of Electrical Wiring, you can see the section 5, inspection and testing. What is the importance of this Code of Practice of Electrical Wiring? You see, most of the fire accidents, if we say 70% fire incidents are due to short circuit, we cannot simply say that it is because of an old equipment, it is because of overloading, it is because of some loose contacts and all. That is not correct. A properly designed, erected and tested electrical installation shall ensure that in case of an overload, your device should trip. In case of a bad device, your protective device should trip. In case of a loose contact, your device should trip. Before it makes a fire, the protective devices are supposed to operate and it is supposed to disconnect the supply. And that is how, or that is why, or that is the measure against fire and electrocution. Now the section 5 of IS 732, remember how many years back it is, 32 years back, has included inspection and testing of an electrical installation, which has got A to M, different kind of testings are there, a lot of things are there. I am only showing you the testings. Out of that, these testings, let us say for example, the test number C, earth electrode resistance testing, except this particular test or sometime insulation resistance test, none of the other tests are made in an industry. So an industry who is claiming, I have made everything for electrical safety and the safety first posters and safety first audits and all these things, and if you have not tested your electrical installation for all these things, you cannot claim that you are satisfying the requirements of electrical safety, of course, because you are not testing. Simply claiming will not help. Now, how this is written in the, what kind of inspection is required as per the regulation? Please understand, the Government of India, Central Electricity Authority has got the regulation, CEA measures relating to safety and electric supply. Regulation 33 talks about the protection against leakage, and here the sub-regulation number 2 says every electrical installation not exceeding 650 volt shall be at least 1 mega ohm. What is this? This is nothing but the insulation resistance testing. to ensure that the appliances, connected devices are not creating any leakage and the electrical wiring is not creating any leakage. This is a mandatory testing. And the regulation 30 says this test shall be done in every 5 years. Regulation 40 says this test shall be done before a reconnection. And who has to do this test? It is for the electricity supply company. The electricity board or the electricity supply company is supposed to do this particular test. You know, in last years, I was traveling across India and visiting several electrical supply companies. And once when I take my class and once when I ask, are you doing this particular test? Majority, 80% says, 50% doesn't know about this test. 30% says, no, we don't do this test. And 20% says, yes, the technician, the electrician does this test. We don't know whether he is really doing the test or not, but he submitted test report. So basically, the test reports are submitted to the electricity board, but nobody knows whether it is really tested or not. Please understand that these tests are included in the regulation. This is the bare minimum requirement for electrical safety. And most of the low voltage installations, especially high-rise buildings, in high-rise buildings, the individual apartments are low voltage LT consumers, LV consumers, and the electricity supply company is supposed to do this particular test. And if you don't do this, of course, your electrical installation can catch fire. This regulation is existing in India since 1937. In 1937, Electricity Rule 1956, Indian Electricity Rule and 2010 regulation, everywhere the same system is existing. And sometimes people ask why this is not updated so far. Of course, writing the entire testing and audits in the regulation will only run several pages. There are other documents available. The regulation 12.2 says you should refer anything more than this for achieving safety. You should refer the code of practices by the government of India. So, in order to achieve safety, the first point is you must measure the insulation resistance value. This is the bare minimum requirement to ensure safety. You should do it every 5 years. And if you have any addition or replacement, or if you close your factory or premise for certain time, you are supposed to do it again. And unfortunately, majority of the electricity supply companies are not following this particular requirement. This is, as I said, the bare minimum requirement. And if you are not satisfying this bare minimum requirement, of course, your electrical installation can catch fire, or it can even do some astonishing accidents. Now, for anything more than this, the regulation says, 12.2 says, NEC or other code of practices to be followed. So basically, once when we start from our rule by the government of India, the rule is the regulation, safety regulation. It says you should do the insulation resistance or the measuring, for example. The simple name is measuring. So you should do the IR test, and more than that, you should do as per what is written in the NEC and other code of practices. So I shown you in the previous slide, IS 732/1989 has included 10 different testings, and we don't do it now. So if you have not carried out this particular testing, you cannot call your electrical installation as safe. Number two, how does this code of practice comes? What is the basic? Who is making these requirements? So basically, worldwide, every country, be it America or European nations or the developed nations, everywhere the uniform international standards for electrical safety is used. The same standard or the same systems are used everywhere, which is based on the TBT agreements of the World Trade Organization. The standard called as IEC 60364. This is the only standard which has to be referred and used worldwide for designing, selection and erection and verification of a low voltage electrical installation up to 1000 volt AC and 1500 volt DC. The same standard is been adopted in Britain as BS 7671, in Germany as DIN VD 100, in France as NFC 1500, in America as NFPA 70 or NEC National Electrical Code of America. So the same system is used worldwide, and in India, the same system 60364 is called as IS 732, Code of Practice of Electrical Wiring. We have seen in a lot of tenders, for example, even some of the metro, new metro construction sites, they are asking in the tender document, they are asking to satisfy the rules of BS 7671, NEC of America. Nobody write the Indian standard. That means, you are trying to follow the Britishers and Americans even today. No need for it. We have the most modern standards, and you must follow this particular code of practice, and which is followed everywhere. All the other nations are doing it, and these standards are talking about design, erection, and testing of an electrical installation. Now, what do we mean by verification or design, erection, and testing? Testing, the last one, testing, means it is not only testing, it is called as verification, consisting of inspection and testing. I'm just showing you a picture just to inform you that in your electrical installation, probably you will have a high voltage system. In that particular case, you must follow the rules of IEC 61936 Part 1. An equivalent Indian standard is already on the way. Probably very soon there will be an Indian standard on this particular case. On the low voltage side, we are supposed to follow 60364, which is nothing but the IS 732. Actually, it is not only IS 732, IS 732 plus the National Electrical Code of India. So basically, in a low voltage electrical installation, the fixed part of the electrical installation, I would say the distribution boards, the wiring, the sockets, the fixed part must be tested as per IS 732, and all the connected devices, such as, let's say, for example, low voltage machines. If you have an industry and if you buy a machine, and once when you install that particular machine, you must do the testing as per IEC 60204. The second one, lift and elevators. Of course, in most of the modern buildings, you have the lift and elevators, and you must do the testing as per ISO 8100 Part 1. There is an Indian standard already in the making. Probably very soon that particular standard will come out. Then safety of electronics and building automation system, a different standard. UPS, there is a different standard. Bonding and information communication technology equipment, there is another standard. EMC, another standard. So basically, your electrical installation, depending upon its criticality, you are supposed to ensure compliance of several standards, or the subject is covered not in one book, it is covered in several books. You are supposed to understand and do it properly. Or I would say, the electrical safety engineer who is doing the safety audit, he must be aware of the requirement of all these standards, and then only he will be able to do a proper electrical safety audit. I will explain two examples. One is the IEC 60204, because if you have a very good electrical installation tested, but if your devices connected, such as elevators, if those are not tested, then we are not meeting the safety. So I am explaining you what is written in the 60204 standard and the ISO 8100 standard Part 1, which is the latest standard for lift and elevators, which is, both are becoming Indian standards very soon. Now, the first one, 60204, clause number 18 talks about verification. 18.1 talks about, ABC and G. These are, some of the important verifications, because A, B, C, and H are very much important, and sometimes D to G need not be done, and there are some excuses and all. Now, let us not worry about it. Now, always, all the product standard, the first verification is verification that the electrical equipment complies to its technical documentation. That means you are getting a catalog, you are getting a brochure, you are getting some manuals, you are getting test reports, first to find out whether these are up to the most modern or up to the standards which is claimed by the manufacturer. That has to be verified first. That means the person who is doing this job, he must be aware of the standard, and he should understand what kind of testings are required for each and every equipment, and he should do it properly. The second actual test, verification of continuity of protective bonding circuit. What exactly is this? Every standard, every equipment when you buy, if you are buying a motor, if you are buying a drive, if you are buying an air conditioner, if you are buying a some kind of fittings in your house, so you are supposed to do this particular test. Of course, for smaller things you don't need to do it, but in an industrial environment, of course, you are supposed to do this particular test. And always the second test is, in case of fault protection by automatic disconnection of supply, condition of protection by automatic disconnection of supply shall be verified. So these two tests, one is continuity of protective bonding circuit and fault protection by automatic disconnection of supply. These two I will explain with videos to you for your information. So basically, every electrical item which you are connecting to your installation also need to be tested. 18.2, verification of condition of protection by automatic disconnection of supply. So, I will cover this a little bit later. And the first test, you see, verification of continuity of protective bonding circuit. What is protective bonding circuit? Every building, every installation, a low voltage installation, you are supposed to have a protective bonding circuit or equipotential bonding circuit or protective equipotential bonding circuit. Out of this, somebody had asked what is the meaning of protective, what is the meaning of bonding, what is the meaning of equipotential. Bonding is a connection. Equipotential means there is no potential difference between two parts. Protective is safety. Protective equipotential bonding means for the purpose of safety, you are making an equipotential bonding. Means different metal parts in your building are connected by means of metal wire so that there is no potential difference exist in that particular building. That is the basic idea. So this is actually verification of continuity of protective bonding circuit. That means you have a wire which you are using for this particular connection, and you should measure the resistance of that particular wire and you should compare it with the reference. Number two, fault loop impedance and verification of suitability of associated overcurrent protective device. So this is the test number two. Both these tests I will show with the video so that you will be able to understand it better. Now let me go to the standard ISO 8100, which is the lift standard, passenger lift 6.3.2. This clause talks about the verification of electrical installation. The first one is, as usual, visual check. The second one is continuity of protective conductors according to IEC 60364 part 6. As I told you, you see, for all the basic things, 60364 part 6, or this is the base standard for any kind of verification in a low voltage installation. Now what you should do is continuity of protective conductors. How do we do continuity? Sometimes we do continuity with a multimeter. You take a multimeter and check a fuse. It makes a beep, beep, beep sound. Okay, you have the continuity. Actually here, what is written, the continuity of protective conductor. This is not about checking whether the multimeter is making the beep. This is little bit something different. Then the next one, effectiveness of measures for fault protection. So for fault protection is nothing but a shock protection. You have some measures which you have included and those measures are working or not is the second verification. Now, whenever if you read continuity of protective conductors, don't think that this particular test is with a multimeter. You take a wire and once when your multimeter is connected, it makes a beep beep sound, and we generally call this as continuity test. Actually, the continuity of protective conductor or continuity of final ring circuit conductor, what is written in the standards are not about this particular test. It is something above. So it is actually about measure the resistance of the wire accurately and compare it with the reference. So that is what we are supposed to do. I am just going to show you a video, but you see this video is made in our a kind of a lab, so you cannot see a professional video. One moment, please.
Hi Gopal, there's no audio. You're muted.
Oh, I am so sorry. Actually, I was talking here.
There's no audio. I think by mistake it's on muted. Yeah.
Yeah. Sorry. So I am just showing the video again. Sorry for that. So we are going to measure the resistance of 2.5 square millimeters wire, about 20 meters of 19.75 meter in each length. For example, totally 39.5 meters. The wires are shorted at one end. Then we use 3 meters just to show you, or just to explain you, that the accuracy of the meter is equally important. Here actually we shorted the neutral and earth together for temporary, because this is a switch in this test which has to be done in off condition. Then on the distribution board we do the testing with a microometer. 4-pole test in a microometer, the continuity resistance shall be measured, and it is approximately 315 or 316 milliohm. Then the same test, just for your information, the same test is carried out with a multimeter, a normal multimeter. In a normal multimeter, you get the value as 900 milliohm. See, 900 milliohm, this is the final value. And then we also do the testing with a different meter. So these 3 meters are of 3 different test currents. The first one is the accurate one, and the last two and 3 are not accurate. So basically we get a higher value, 410 milliohm. So what you should do is, first you should understand what kind of wire it is, what is the size of the wire, and you should understand what is the length of the wire. Then you get a good and very accurate meter. You test the continuity resistance of that particular wire. Then you go to the reference value which is there in the IEC standard, IEC 60364, or the upcoming National Electrical Code. You take the value 2.5 square millimeters of wire, 7.5661 milliohm per meter. So here we have 7.56 about 39.5 meters. Approximately we are supposed to get 299 milliohm, whereas our meter has shown 315 milliohm. So the actual test result must be lesser than 255, whereas we got a value more than 315 milliohm. Why? We actually, technically, we have failed this particular test. The reason for this failure is the values given in the reference standard is for class 2 copper. You should understand that copper, there are 4 types of copper conductors available, or 4 types of copper is used in a conductor: class 1, class 2, class 5, class 6. Out of this, class 1 and class 2, class 1 and class 6 cannot be used. Class 1 is a solid conductor, class 6 is for welding applications, so both are ruled out. Class 2 and class 5 are actually PVC insulated conductors. Let it be, the FR, FRLS, or all these things. Basically, PVC insulated wire. There are PVC insulated wires are available with the 2 type of conductors, class 2 and class 5. Now you look at the resistance of both the wires, 7.41 and 7.98, 7.56 and 8.21. The second one is actually the resistance of the tin plated copper, and the first one is the bare conductor. So basically, if we calculate 7.98 into 39.5 meters, then we accurately get the value which we got, 315.21 milliohm. So basically, we have failed the test because we used the class 5 conductor, which we are not supposed to use for the fixed part of the electrical installation. For fixed part of the electrical installation, we are supposed to use copper wires with the class 2 copper. Means the copper must have a very less resistance in comparison, about 8%, 9% lesser resistance. Actually, World over, class 2 copper wires are used for wiring in a building, whereas in India, sometimes class 2 copper wires are not available in the market. If you have any doubt, you can check with your wire supplier, you call them and find out whether they have class 2 copper wire in their stock. Most often, these are not available in the stock, and most often the electricians and people doesn't know about it. As a result, we always use class 5 copper, plastic PVC wire with class 5 copper. The danger of this wire is resistance is high. As a result, more heat is produced inside the conduit. Technically speaking, the derating factors we are supposed to change. We are supposed to use a higher derating factor. Say, for example, yesterday in a webinar, 2 days back in a seminar, one of the engineer told, we have a particular motor, and always if the capacity is this much, we use 2.5 square mm wire, or let's say 4 square mm wire. Then when I asked, okay, what kind of derating factors you are applying, they said, no, we don't apply any derating factor. Manufacturer's catalog says this can handle, example, 25 amps current, and we simply use it. Actually, we are making mistake. We are, depending upon the installation, depending upon the length of the wire, we are supposed to use derating factors. And now our problem is, for all these derating factors, class 2 wire is considered, which is having a lesser resistance. And if you use a wire with a higher resistance, of course, you will end up with trouble. So we are not supposed to use a wire of class 5. Basically, what I wanted to tell you is, if we do the testing in 100 buildings in India, almost 99.9% the test is failed. So whatever the safety first and the posters which you are claiming is just, just to show, it's just a marketing. This is what I told in the beginning. The safety, whatever we are claiming, we are actually not following, or we are not actually doing it. It is done only in posters, especially the electrical safety. Now let us go to the test number 2, which is to test the automatic disconnection of supply. What is automatic disconnection of supply, and why this is important? Basically, shock protection is achieved by 2 methods: basic protection and fault protection. We have explained it in our earlier webinars, but still I will explain it again. Basic protection means direct contact, protection against direct contact, and protection against indirect contact. So different techniques are used for this particular purpose. In the most commonly used fault protective measure is called as automatic disconnection of supply. So in the standards and technical books, you will be able to read as automatic disconnection of supply. But if you go to the definition of automatic disconnection of supply, what it does is, automatic disconnection of supply is a protective measure which is achieved by protective equipotential bonding and automatic disconnection of supply. That means this safety measure consists of 2 things. One is protective equipotential bonding. Means, on this particular graph, what you are seeing is the permissible touch voltage. The maximum voltage, fault voltage inside your installation must be reduced to less than this particular voltage. Don't cross this voltage. Be it low voltage installation, high voltage installation, or extra high voltage installation, the permissible touch voltage is as per the IEC, which can be, you can see this figure in several standards. I'm showing the figure from the IS 732, figure number 28. So this is the maximum permissible touch voltage. What do you do to achieve this minimum permissible touch voltage? You have to make equipotential bonding, which is coming on the next slide. Then here, this is the disconnection time. What is the disconnection time, or what do we mean by disconnection time? It means the protective device should trip within certain time in order to achieve safety. So in order to make the second test, which is called as the efficiency of automatic disconnection of supply, first you should understand what kind of safety measure is implemented in your building. Then you must understand how the protective equipotential bonding is carried out. I am showing a picture where you can see M stands for exposed conductive parts. What do we mean by exposed conductive parts? Means class 1 equipment which is having an exposed conductive part are connected to MET, means a common bus bar, Item number C, like the metallic pole or the metallic ducting or metal pipes, these are also connected to the MET, means the main earthing terminal or equipotential bonding terminal. So basically all the metal parts in your building are interconnected to a bus bar. That particular bus bar is connected to an earth electrode if you have a TT system, and it is actually connected to the source neutral of the transformer or DG if you go for a TNS system or a TN system. So basically for industrial and commercial installation, we are supposed to follow TN system. So for TN system, your bus bar in your building at the main distribution board must be connected back to the source, not to the earth electrode in soil. And this is called as protective equipotential bonding. So for easy understanding, if we look at the regulation, don't think that this is required. This is actually not required because we are not going as per TT. We are supposed to go for TN system. So basically, all the metal parts in your building must be interconnected, and this is called as protective equipotential bonding. Now the safety auditor should make a test for it, just to ensure that the touch voltages are lesser than the limit which is explained in the standard. But unfortunately, most of the buildings in India, including high-rise buildings, this safety measure itself doesn't exist. If the safety measure doesn't exist, where do you test? The protective equipotential bonding is achieved by protective earthing of all exposed conductive parts to MET and protective bonding of all extraneous conductive parts to MET of the installation. MET shall be connected to the means of earthing depending upon the system earthing, sometime to the earth electrode or sometime to the the source of the transformer. Now, what do we mean by disconnection time? In your electrical installation, you have a transformer, you have the meter board, and then you have the fixed part of your electrical installation. Up to the meter board, if you are getting a public electricity supply, the disconnection time is fixed by the energy supplier. In most of the European nations and America, there is a fixed rule exists, whereas in India, there is no rule. So even in case of a fault in the public distribution, it may exist for several days or even sometime months. Whereas actually, foreign countries, developed nations, they have clear rule. So the fault shall not exceed for more than, let us say, for example, 1 hour. Then we come into your electrical installation. The fixed part of the electrical installation, the main distribution circuits, in case of a TN system, the disconnection time is 5 seconds, and in case of TT system, less than or equal to 1 second. And the final circuits, the load circuits and final circuits, especially up to 63 amps with socket outlet devices and 32 amps fixed equipment, the disconnection time recommended is 0.4 seconds in TN system and 0.2 seconds in TT system. So what I wanted to explain to you is, before making the test, you must understand what kind of safety measures are implemented there. What kind of system earthing is it? Is it TT system or TN system? And if it is a TN system, what kind of distribution it is? Is it the final distribution or the main distribution circuits? And based on that, first we need to find out the maximum disconnection time. Then based on the maximum disconnection time, you have to select the appropriate protective devices such as OCPD. Please understand that the fault protection, the primary protective device recommended is OCPD. OCPD means the overcurrent protective device, which is nothing but fuse or MCB or MCCB. This device is supposed to disconnect at the primary phase. Now, before going into that, you should understand that each of these devices has got a disconnection curve. So it do not overcurrent. For example, you have a 10 amps MCB. If 11 amps comes, will it trip? Of course, no. At 10 amps MCB, at 11 amps, MCB will not trip. MCB require up to 1.13 times the current. That means 11.3 amps current. MCB will need not have to trip. If the current is up to 1.45 times the rated current, it can take up to 1 hour to trip. So basically, these protective devices are used for two purposes. Very important to understand. these two purposes, the first purpose is these protective devices are to protect the wiring and the circuit. This means it is not to protect your equipment, because your equipment is supposed to have its own protective measure against overcurrent and short circuit. Now, these protective device, the first job is it has to protect the circuit, number one, and in case of any earth fault, these devices are supposed to protect against a shock voltage. So two purposes are served by the OCPD. Now, to select it, first you should understand the difference between overcurrent, short circuit, earth leakage, and earth fault. If you don't understand the difference between these four, then of course you cannot handle it properly. Earth leakage and earth fault, fault means always when we call as a fault, it means an earth fault means live conductor is in touch with a metallic object, which is not a current carrying conductor. So an insulation reduction between two current carrying conductors are always called as probably overcurrent or short circuit, whereas between live conductor and the earth means a metallic body which is not a current carrying conductor is called as earth fault. So we are talking the automatic disconnection, we are talking about earth fault. Of course, for the first two overcurrent short circuit, other curves are applicable, and the wiring also should withstand, all these things are there. But here the most important point is with respect to earth fault is the earthing system shall be made in such a way that whenever there is an earth fault, the earthing system shall ensure that enough current flows, large amount of current flows through the circuit so that your protective device is disconnecting the fault. That is the fundamental requirement for earth fault protection. Means whenever there is an insulation failure and if an equipment is creating an earth fault, the circuit must be designed in such a way that enough fault current flows and it disconnects the supply. That is the fundamental of electrical safety. Now, but whenever it comes to good practices in earthing, what do? We have a lot of earth electrodes in soil, which is absolutely, I always say this is a mistake. You are not supposed to have so many earth pits in your building. One building requires sometime only one earth electrode. You don't need to have so many earth electrodes. So basically, what we are talking is how to disconnect the supply. And disconnection of supply means you have to have a very low fault return path to the source. Fault current never goes to earth, it returns back to the source through a metallic conductor if you have. That is the most efficient way. And now the IS 732 says, these calculations are given. The fault loop impedance shall be lesser than or equal to the operating voltage divided by the operating current of that particular OCPD. Now the rating of the fuse comes into picture, rating of the MCB comes into picture, its disconnection current comes into picture, then finally the fault loop impedance comes into picture. In the upcoming National Electrical Code, we have included this particular table, which gives you some information about the type of MCB and the required fault loop impedance. Of course, I will show you in the next video how you should test it. But before making the testing, the idea is you should understand what exactly it is. If you don't understand what exactly fault loop impedance is, and if you do the test, we will be in deep trouble. Why I am making this statement repeatedly is, most of you are aware that I am making a lot of training classes, a lot of awareness classes. After every awareness class, I get at least 10 to 15 emails or phone calls combined. Then people ask me, okay, how to do a safety audit? You send me the tender specification. I will call a tender. I will put it in my my document, and I generously give these documents. 2 weeks back, I got a call from a client, and he was making a complaint, and he said that, look, with your tender specification, I called a tender, and 4 parties participated, and now finally we realized that they don't know to do the test. They don't know what exactly the test has to be done. Can you give training for these the safety engineers? So this is actually a pathetic, not a good situation. So what I wanted to tell you is, if you are doing an electrical safety audit, first you try to understand what it is, and then you do it. If you don't understand, and if you go with a meter and try to test it, it won't work out. Now, fault loop impedance test is a live test. Your supply has to be in on condition, your transformer must be on condition, your DG must be in on condition, and then you should do it, and you have to be very careful. You have to have the proper PPEs to do the test if you are opening a live circuit, especially a distribution board. Now, I'm showing you a test which is carried out again in our facility. For a 10 amps MCB, a circuit where a 10 amps MCB is used. Sometimes people ask, do we need to do even for a 10 amps MCB? Yes, of course, you must do the test even for a 6 amps MCB, because most of the time fire starts from small equipment, small connected load. Last fire in Bombay, it was the newspaper report says fire started from a video doorbell. It's a very small item, video doorbell. Probably it started the fire, but the MCB didn't trip, which has become a major fire accident. So our aim is to ensure that the MCB is tripping within 0.2 seconds. Of course, your equipment, even if it burns for something about 3 seconds, nothing happens. An equipment, a fault or a heat dissipated from an electrical equipment, whatever the amount of the power it is, but if it is disconnected within 3 seconds, then the chance of fire is almost negligible. And this test is actually to ensure that your devices are operating properly. So what the standard says is, every circuit must be designed to cater this requirement. Every circuit must be tested during the installation or before putting it into service. You are supposed to do the test, and every electrical installation you are supposed to do a periodic test. Every electrical installation you are supposed to do a electrical safety audit. The first safety audit must be for this particular test. So it is very simple, but before thinking it as simple, but you must understand the subject, otherwise you will not be able to give the actual safety to the consumer. Now I am just showing you a video. There is a plug, and this power is coming from a 10 amps type C MCB. You are aware that type C MCB require 10 times its rated current to create the tripping, and the meter has got Z L to P. Now also, you see, we are using a very small meter to do this particular test because it's a final circuit, a 10 amp circuit. For a higher circuit, we need to have a more accurate meter. A bigger meter is required. Now, in this particular case, the expected current is something about, the video is coming back. The fault loop impedance with this meter, we are getting a value of 5.58 ohm. See, Z L to P, line to P, RCD means this test is for a circuit which is having an RCD. We are trying to test the efficiency of the MCB, 10 amps MCB. Minimum current is 100 amps because it's a type C MCB. Now we have the fault loop impedance 5.58 and the fault current 43 amps. So it is actually in danger. We require minimum 100 amps to trip the MCB, whereas the current is only 43 amps. So we are technically in danger. Now the same circuit we are testing with line to neutral. In the line to neutral, the current, the fault loop, the short circuit loop impedance is 1.32 ohm, and the current is about 181 ampere. Of course, it is safe. This particular device will trip very easily. Now, why this is happening? Because this particular installation, this is a TT system, TT network. Now, I will skip a little bit of my. We have to change the system to a TNCS, but after seeing my video, a lot of people try to do it by their own and end up with the trouble. So I don't want to do, or I don't want to show how this is carried out. We changed the network to a TNCS network. Then we are doing the test. Now you see the values here. The fault loop impedance is 1.41 ohm. the fault current is 170 amps, more than 100 amps is enough for our, or more than 100 amps our MCB, we are sure that our MCB is tripping. So basically, in order to do this particular test, you must understand what are the fault protective measures and what kind of measures you have implemented in your installation, what kind of protective equipotential bonding is made in your installation, what kind of protective devices are there, what is the disconnection time, and then finally, with a meter, we have to do the test. Last 2 years, I have showed this video at least 50 times to several of my audience. Some people, after looking at the video, of course, which is also there in the YouTube, they started doing the test, and finally the customers started complaining me because after your class, we started doing the test, and now we are in a terrible situation because we don't know what to do. So what I wanted to tell you is, with this 2 hours lecture or 1 hour lecture, don't think that you are able to learn everything about testing an electrical installation. I am only giving some tips. Probably if you have 100 tips, I am only giving 2 tips in this particular video or in this 1 hour. So you need to really understand the system and then only do this test. Now, going back, what exactly the installation test is? Now, one more point in the previous slide. I have shown you this test is required for an electrical machine. This test is required for a lift, for example, an elevator or a lift. To my knowledge, the only company which is doing this test, a lift company which is doing this test is Schindler, a Swiss company. They do this test in every electrical installation and they ensure that the MCB is tripping. But on the other side, clients are always complaining. People say these guys are coming with some test and we always fail, and they are trying to put a type B RCCB and so on. But be sure what is written in the standards and code of practices for safety is you are supposed to do the test and you are supposed to ensure the safety. Now, IS 732, for ensuring safety in an electrical installation, we are supposed to do several kind of inspection. Number one, there are about 19 inspection points, out of which the 19th point I have added extra, which is probably not required in a normal electrical installation, but this is mandatory for a place where you have high sensitive electronics, such as a hospital, such as a data center, such as BMS system and all, instrumentation system and all. So basically, inspection consists of 19 points. Out of this 19 point number 2, for example, presence of fire barriers, other precautions against propagation of fire, and protection against the thermal effect. All these things are actually directly connected to fire protection. Number 9, identification of neutral and protective conductor. As I said, the regulation, minimum 1 mega ohm insulation resistance between live conductors and the earth is the minimum requirement. This also means a minimum of 1 mega ohm insulation resistance is required between neutral and protective conductor inside your electrical installation. If we violate it, actually we are ending up with trouble. But lot of electrical installation, people need some kind of a capsule solution. What do I mean by capsule solution is you give something in a black box which is solving all my electrical safety problems. As a result, there are some black boxes or some devices or some products which is available in the market where manufacturer claim that you install my product, then all your problems are going to heaven. Nothing happens. You will get an SMS before a fault, or as soon as there is a fault, you will get an SMS. But please understand that as soon as there is a fault, your MCB should trip. Before you get the SMS, your MCB should trip. If your MCB is not tripping and if you get an SMS, by the time you reach your house will burn down. So there is no gadget which can offer all the safety. You have to do proper designing, proper selection, erection of the product, and proper testing of your product. Testing or the inspection, it consists of 18 inspection points and 10 tests. starting with the resistance of conductors. Of course, in the standard, you will be seeing continuity of conductors. I changed to resistance of conductor because people are misreading it. So resistance of conductors, insulation resistance, then the third is also insulation resistance. Number 6 is effectiveness of automatic disconnection of supply. And finally, the voltage drop. There are 10 tests. Now, these 10 tests, you have to be sure that you have to see that we are supposed to follow this sequence. For the initial verification means you have a new electrical installation, or you have a modern electrical, or you have an added electrical installation. Before putting it into service, you are supposed to do all the tests. For a periodic test, you don't need to follow all the tests. You can excuse some of them. But again, that is a question depending upon your application. What you should keep in mind is you are supposed to keep the sequence. In case of failure in any of the tests, you have to rectify the defect and you have to redo the previous test onwards after rectification. And in case of potentially explosive areas, you are supposed to take the necessary safety measures. So basically, all these tests are required. Now, here I have put one more test, PAT. PAT is, I would say, it is a 11th test, which is made mandatory in some countries. For example, Australia, if you buy a new equipment, before putting it into your electrical installation, you are supposed to do a PAT test. PAT is called as portable appliance test. Now, you must understand that not only the PAT test, all the tests are important. If you don't do all the 10 tests and do only the PAT test, you cannot ensure any safety. You have to do the entire tests. Misguided test. In Bombay, lot of buildings, high-rise buildings, I've seen people doing thermography in order to find out loose contact in a conduit. You have a wire, a copper wire, 2.5 square mm or 1.5 square mm wire inside a conduit, and thermography has been done to find out a loose contact in a conduit, which is absolutely wrong. This is not the correct way. So you should do it in the proper way. The recommendation is you should do all the basic tests as per IS 732. Say, for example, if you measure or imagine you have completed the wiring in your building, the wires are inside the conduit, and after making the continuity resistance test, if there is a loose contact, you will come to know. So you don't need to have a thermography. The basic test recommended is continuity resistance test, and you have to replace that to loose contact. And basically, the recommendation is you must do the testing as per IS 732 and National Electrical Code as the first safety measure. The first electrical safety measure is you ensure that your installation is conforming to these two particular standards. Over and above, do all additional safety measures such as thermography, arc flash, and all these things you can do extras. But I will put it in one more way. If you don't do the basic test, and if you do only thermography and arc flash, and if you expect electrical safety in your building, you are actually fooled. So you cannot achieve safety. You have to have the must confirmation from IS 732 and NEC. Now, for special location, such as a hospital, you need to have additional test. Let us say, for example, an hospital. In a hospital, we are supposed to have a lot of additional safety measures, such as supplementary equipotential bonding, medical IT system, and so on. All these requirements are satisfied with additional tests. So basically, testing or verification or audit in an electrical installation, low voltage electrical installation, is not about testing the earth electrode resistance. Actually, earth electrode resistance has been removed from the standard few years back. Not few years back, in IEC about 20 years back, earth electrode resistance has been removed. You don't need to do earth electrode resistance test in a low voltage electrical installation, because your electrical installation is the earth electrode doesn't have any influence in your electrical installation with respect to safety or reliability, except lightning protection. Now, as a solution, what we are doing is Solve. Solve is a digital platform which we are developing for the last few months. A group of software engineers are working, and it will have different modules for testing, inspection, and certification, investigation of the electrical faults or failures and the safety measures for special location. All these things are inbuilt into the software. It is still under development. The first modules are already tested and we started using it, but the final things probably it will take another 1 more year to finish this complete development. But of course, the basic things are already ready. Now, Solve can be a partner in electrical safety. It will support you in the design part, but remember only the safety part. It will have modules for training. It will help you in verification of the low voltage electrical installation. At the moment, we are concentrating on the verification part. So you can be sure that your electrical installation is complied to all the standards. You can have what the kind of supports during erection, testing, inspection, and certification. You can do it. You can have long-term contract for periodic test. And all these verification or the testings which is required or safety audits which is required in an electrical installation is inbuilt in this particular standard. So basically, but don't think that the webinar is to promote this particular the solution. The webinars we are doing for last 3 years, but this solution is only now because every time when we have a webinar, people ask there is no one to carry out the audit. Why don't you come out with something? As a result, we started this particular job. So by this, thank you very much for participating in the presentation.